there is yet another way by which we can derive E is equal to minus VLV. Now this was a system which we already saw. Now electrical power is dW by dt. Rate of doing work is power. Now here we are talking of small power. Alright, so dW over dt, and W we know in terms of electrical it is EQ, where Q is charge, E is volt. Now dW over dt is equal to E dq by dt. If we take this dt this side, dq by, and dq by dt is equal to I. So electrical power formula is EI. Yet another formula to be kept in mind. So electrical work dW over dt is equal to EI. So dW is equal to EI dt. That's our equation 1. Now let's talk in terms of mechanical work. Now mechanical work is minus F dx. Why minus F dx? Because displacement is this side dx, and the force which is trying to restore it back is in this direction. So both are in opposite direction, this and this, owing to which it is negative. Alright. So as F we already have derived as BIL. So instead of force, we substitute it as BIL into dx. So this becomes our equation 2. So dW is equal to minus BIL dx. So in this case we are talking in terms of electrical work is equal to mechanical work. So on equilibrating, dt goes down there and it becomes dx by dt, and dx by dt we know is velocity. EI is equal to minus BIL dx by dt. dx by dt is V. So I gets cancelled. So E becomes minus BLV, this being velocity. Alright. Now let's try and understand self-induction. Of course, this is the circuitry system. This is the inductor, to which is connected a rheostat, battery and key. Now we know the property of inductor. Whenever current passes through, it generates back EMF. Now suppose the battery which we have put in is for 1.5 volt. As soon as we press in the key, there is growth. So growth, what do I mean by growth? Growth means the voltage, it is before gaining 1.5 volt, it has to rise from 0.1, 0.2, 0.3, 0.45. So there is change in EMF. Now since there is change in EMF, now owing to that change, there is back EMF generated. There is back EMF generated. So while growth, there is back EMF generated. Again, it gets stable at 1.5 volt. Now again, if I open the key now, so when I open the key, it's decay. It's falling down from 1.5 to 0, 1.4, 1.0. So there's a change in EMF. Owing to change in EMF, there again is generation of back EMF. But mind you, the direction of back EMF is opposite in both the cases, because here it is growth and here it is decay. Alright. Whereas at this stage there is no back EMF generated, because back EMF is generated only when there is change in potential, that we have seen in Lenz's law. Alright. Where only when there is change in flux does the EMF generate. Alright. So that's one situation, a closed and open key system. So that's all with self-inductance. Now let us understand a bit of mathematical aspect of it. Now flux is directly proportional to current. We know that more the current, more the flux. And if this goes in case of inductance, it is L, which is constant of proportionality. So flux is equal to Li. Now if there are more number of coils, then it would be N flux proportional to I. So N flux is equal to Li. This is one setup that we have got to keep in mind. Now E is equal to minus d phi by dt. This we have learned as Lenz's law. So phi, if we substitute, phi, if we substitute, it would be Li. So we substitute it here. So E becomes L di by dt. Or if I want to talk in terms of L, this thing would go below E. So this thing would go below E. So we're talking in terms of mod. So negative has been taken care of. So mod E divided by di by dt is L. So unit of this is volt, di is ampere, and dt is second. Now unit is Henry. Alright. Now electrical power is equal to dW by dt, which we saw right now, which is equal to EQ by E dq by dt is equal to EI. So dW is equal to EI dt. This we derived right now. Now we know W is equal to EQ, or dW upon dt is equal to EI. This we have already seen so many times. So dW is equal to EI dt, and E we right now checked out was equal to minus L di by dt. So we substitute that. Instead of E, we put in minus L di by dt, and we also have I dt over here. Dt gets cancelled. So dW gets the formula of minus Li di. Now this is small work. So we have got to get total work. So for total work, what do? We integrate it. We integrated from where? We integrated from 0 to maximum current I0. Alright, we knew that the formula had minus, so minus is there, still there. Li di, we know L is constant, so that comes out of integration, and then I di, we are to integrate I di. So on integration of I di, it gets the form of I square over 2, minus is there, L is there, which is a constant, and 0 to I0. When we substitute as per law of integration, we get L0, this comes first, so L0 square upon 2 minus this value comes 0 square upon 2. So what ultimately we end up is minus Li0 square upon 2. And if we talk in terms of magnitude, then W is equal to Li0 square. I0 is maximum current, square upon 2. So this is yet another formula which has got to be kept in mind for work in terms of inductance, self-inductance. Alright. Now moving forward, we are talking in terms of energy of circuit. Half Li square, that is what we derived right now. Now mechanical kinetic energy, the formula is half mv square. Therefore, rule of L of electrical circuit is same as mass. We know mass is inertia in mechanical motion. So W is equal to half Li0 square. That's one thing that we have got to keep in mind. So is same as mass energy in mechanical motion. That's one thing we have got to keep in mind. Again, we know this formula. If we substitute I0 as 1 ampere, alright, so L becomes twice the work. So self-inductance of a circuit is twice the work done in establishing magnetic flux associated with unit current in circuit. So L is equal to twice the work if I0 current is 1 ampere. Alright, so these are the things. So again, the formula for energy of circuit has to be kept in mind, which is half Li0 square. Alright.